So I don't know why, but I can't find the one where I already filled in the degrees, but it's okay because y'all have yours. So let's fill in radians real fast. So the easy way to do radians, I mean, we could do what I've told you guys before, and I could go, okay, well, this is a piece of pi, and then we half the pi, so this is half pi. And then we'd fourth the pi, so this is pi over 4, and this is 3 pi over 4, because pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. But the other thing you can do is, because they gave you quadrant 1 this time, they're all reflections of each other. So the pi 6s are going to be in the same location. So the one that's here, over here, there has to also be a pi 6. Yes? Everybody okay? And if this is pi, it would be 6 pi over 6. So if you back up 1, what does this one have to be?
4. 5.
5 pi over 6. So, okay. So if this is pi over 4, then there's one on the other side that matches it. It's also 5 pi over 4. And this is 4 pi over 4 because it's pi. So if I back up into quadrant 2, that would make this 3 pi over 4. So same thing with the pi 3s. If this is 3 pi over 3, then this one is 2/3 pi, or 2 pi over 3. All right, now we're going to go down. So you can do the same thing. So let's do quadrant 4 first because it's easy. So if this is pi 6, then that means this one over here is pi over 6. They already gave it to you. It's 11 pi over 6 because this is 2 pi, which if you put a 6 with 6's on bottom, that'd be 12 pi over 6, right? Because 6 goes into 12 twice. So the next one up is pi over 4. So this next one is going to be a pi over 4. Well, 2 pi would be 8 pi over 4, right? Because 2 times 4 is 8, so it'd be 8 pi over 4. So if I back up one from that, what is that? 7 pi over 4. All right, so my pi 3s, well, this is pi over 3. If 2 pi was written in 3s, it would be 6 pi over 3. So I'm going to go back up one from that. So this is 5 pi over 3. All right, so I'm going to start here and use my pi 6's because they're reflections of each other. So this is a pi 6, so this is a pi 6. So 5 pi 6, 6 pi 6, 7 pi 6. Pi 4s, 3 pi over 4, 4 pi over 4, 5 pi over 4. Pi 3s, 2 pi over 3, 3 pi over 3, 4 pi over 3. Straight down is 3 times pi. All right, so now that's really all you need. You should have your degrees and your radians on there. The ordered pairs, we're not going to fill those in because number 1, it gets crowded, and number 2, I submit, you don't really need to know all of the ordered pairs because they're the same. All you do need to remember is from back in 5th grade when you learned that everything in quadrant 1 is positive, positive. Everything in quadrant 2 is negative, positive. Everything in quadrant 3 is negative, negative. And everything in quadrant 4 is positive. You know that, you know pretty much everything else. All right, so I did not teach you guys the left-hand trick yesterday, did I? I didn't think we got that far. All right, so let me real quick teach you the left-hand trick because I also submit, if you know the left-hand trick now, you do not have to know the left-hand trick. There are people who do not bother. They just memorize. If you're a great memorizer and you like to memorize numbers and stuff, go ahead and memorize quadrant 1 because you need to know it. But I teach the left-hand trick as a way of not having to memorize it because it's a way of reminding you what the ordered pairs are. So first, it's going to help you with just quadrant 1. This is 0, this is 90. We'll do it in degrees first. There are 3 important angles. 30, the smallest one first, 45, which is the next biggest one, and then 60. Everybody good so far? And they have these ordered pairs, right? The first ordered pair is the square root of 3 over 2 and 1/2. So these are the things I'm trying to remember, right? All right, so here's how it's going to work with your left hand. If I turn my left hand over, it becomes quadrant 1. My pinky is 0. My thumb is 90. My fingers in between are the 3 important angles. The smallest one is 30, this one is 45, and the top one is 60. So if I wanted to know the ordered pair at 60 degrees, I'm going to fold in the 60 finger. And that leaves me with 1 finger on top and 3 fingers on bottom. So I'm going to write down in order a 1 and a 3 as my ordered pair. But these ordered pairs, sorry, I don't need to move that down. But these ordered pairs on the unit circle are all divided by 2. So I'm going to divide them both by 2. And they also all have taken the square root of the top. So I'm going to take the square root of the top. Now, there's no reason for me to write the square root of 1 because what is the square root of 1? Just 1. So that one I don't put a square root on. I just leave it as plain old 1. And that's the ordered pair at 60 because that's what my fingers told me. I could also look at the unit circle chart and see that is in fact the ordered pair at 60. So if I go to the ordered pair at 45, I fold in my 45 finger. I have 2 fingers left on top when I do that and 2 fingers left on bottom. All of the ordered pairs on this table get divided by 2, and the square root is taken of the top. That's the ordered pair at 45. The ordered pair at 30, 3 fingers on top, 1 finger on bottom. All of these ordered pairs are divided by 2, and you take the square root of the top. That's the ordered pair at 30. Okay? So you don't even have to memorize it, you just use your hand. Okay, so we're going to practice a little bit, and by the time we're done practicing, I promise you'll be like, oh, I get it, no big deal. Okay, so, there it is. So, at the, I know, it's terrible. Okay, so the bottom of the page, okay, so the other thing I want to remind you is over here, we did sine over, for sine and cosine and tangent, we started out with opposite over hypotenuse and adjacent over hypotenuse and opposite over adjacent, but then we put them on the rotation angle, and it became y over r, x over r, and y over x. When we put them on the unit circle, the r value, your radius, is 1. So y over r becomes y over 1. And y over 1 is just y. So sine is y, cosine is x, tangent is y over x. And that's what this is right over here. So sine is y, cosine is x, and tangent is y over x. And then the other 3 are these things flipped over. All right, so with all that said, let's jump down here and we're going to start using our unit circle. So tangent of 225, well, first thing I have to figure out is where is 225? What quadrant would you be in?
3.
Okay, I'd be in quadrant 3. And if I'm at quadrant 3 with a 225-degree angle, what's your reference angle?
45.
45. It ends in a 5, so that's your indication that it's probably 45. So I'm going to go to my hand, and I'm going to fold in my 45 fingers. So this is 30, 45, 60. So I'm folding in my 45 finger. So my ordered pair would be square root of 2 over 2 and square root of 2 over 2. So that would be my x and my y. So if I have this ordered pair, it's going to be square root of 2 over 2 and square root of 2 over 2. But tangent is y over x. Well, that's square root of 2 over 2 over square root of 2 over 2. Those two numbers are the same. What happens when you put a number over itself?
1.
It's 1. So this is tangent equals 1. Now, I do have to check because I was using a reference triangle, a reference angle of 45. In quadrant 3, is tangent positive or negative?
Negative.
Tangent in quadrant 3? Tangent's positive in quadrant 3. Remember, all students take. So in quadrant 3, tangent's positive, so it is positive 1. Do y'all smell the heater? I can't believe the heater just kicked on.
Yeah, it's getting cold.
Oh my gosh. It's crazy. Is it getting cold outside? Oh, I didn't know that. Okay. Well, that explains that. Okay.
You're like 41.
So let's do cosine of 5 pi over 6. What quadrant would 5 pi over 6 be in? Quadrant 2. All right, so I'm in quadrant 2, and I'm going to use my reference angle of pi 6. Now, the angles are the same, so it's 30, 45, 60. For in radians, it's pi 6, pi 4, pi 3. If you play baseball, it's a 6, 4, 3 double play. 6, 4, 3, 2. So if you don't play baseball, fractions, so if you cut your pieces of pie into 6 pieces, they're smaller. And then 4 pieces is a little bigger, and 3 pieces would be bigger than that. So a sixth is smaller. That's why this is pi 6, pi over 6. This is pi, anyway. So pi 6, I'm folding in this finger. Cosine is the x value of the ordered pair. So all I need are my top fingers, my x fingers. So it's a 3. All of these are divided by 2, and you take the square root of the top. So now I just have to determine whether or not cosine is positive or negative in quadrant 2. Is cosine positive or negative in quadrant 2?
Negative.
It's negative, because the only thing positive in quadrant 2 is sine. All right, let's do cosecant of 5 pi over 3. What quadrant are we in? 5 pi over 3. Quadrant
4.
Quadrant 4. All right, 5 pi over 3. My reference angle is pi thirds. 6, 4, 3. So this one's the one I fold in. Cosecant goes with sine. Sine is your y value. So I have to take the fingers on bottom, and there are 3. I always divide it by 2 and take the square root of the top. But that's sine, and this is cosecant. So this has to be flipped over to make it cosecant. So that's going to be 2 over the square root of 3. Can you leave it like that? Unfortunately, I still wish we could, but we can't. So we have to rationalize. Multiply both by the square root of 3. 2 square root 3 over 3. And then in quadrant 4, is cosecant positive or negative? Negative. Because the only thing positive in quadrant 4 is cosine and secant. Are y'all kind of a little bit okay? Getting there? It takes practice. It just 3 pi over 2. Where is 3 pi over 2? 3 pi over 2.
It's on the y-axis.
It's on the y-axis. Up or down?
Down.
So what's the ordered pair down there?
Negative 1, 0.
The ordered pair is
Oh, wait.
0.
0, negative 1.
0, negative 1. And sine is the y value.
So you're just negative 1.
Just negative 1. Okay, secant of pi over 4, quadrant 1. I don't need a reference angle because it is a reference angle. So your pi 4, this is 6, 4, 3, so it's the middle fingers. Secant is cosine flipped over. So it's my x value that I need. That x is a 2. It would be over a 2. You take the square root of the top. But that's cosine. And I need to flip this over to make secant. That's 2 over the square root of 2, which you have to rationalize. 2 square root of 2 over 2, the 2's cancel. So it's just square root 2, and it's in quadrant 1, so everything's positive there. Look, this stuff about flipping and rationalizing, I promise you will use them enough that you'll get to where you can rationalize it in your head, or you'll recognize them, I promise, because we're going to do a bunch of this. Okay, cotangent of 180. Where's 180?
Axis.
X-axis, and it's over to the left, so what's the ordered pair over there?
Negative 1, 0.
Negative 1, 0. Cotangent is tangent flipped over. So tangent is y over x, so cotangent is x over y. So that would be negative 1 over 0.
So it'd be 0.
Undefined.
Oh, wait.
Undefined. All right. So we're going to skip this middle page because this is just a bunch of reviewy stuff. We just filled this chart out the other day. This is also in calculus. That stuff is just review. Let's jump onto this stuff because this is more practice with what we're doing. So I want to make sure that you get what you're doing here. So I'm going to do some of them with you, and then I'm going to let you do some on your own. You probably won't do them all, but then we'll go back and we'll make sure you got the ones right that you worked on. So cosine of 210. What quadrant would 210 be in?
30. Oh, wait.
You're right. Quadrant 3. All right, so if I drew 210 degrees, what would my reference angle be?
30.
30 degrees. All right, so left-hand trick, 30 is your first finger. So cosine is your x value. So that's my top fingers. So there's 3 over 2, take the square root. That is the trig value of a 30-degree angle. That is quadrant 1. But I'm in quadrant 3. So in quadrant 3, is cosine positive or negative? All right, so that's all I do is I just take the trig value of my reference angle and I make sure it's negative because my angle is actually in quadrant 3. All right, 7 pi over 4. What quadrant?
4.
Quadrant 4. Reference angle, I love radians, it's just pi over 4. 6, 4, 3, so fold in 4. Cotangent is x over y. So really quick, if I have x over y, so this is square root of 2 over 2, and square root of 2 over 2. So x over y, that would make this nasty fraction, square root of 2 over 2 and square root of 2 over 2. Oh, well, that's just 1. Now, in quadrant 4, is cotangent supposed to be positive or negative? Negative. All right, questions so far? Y'all okay? Kind of? Okay, good. Let's do cosecant of 150. What quadrant are we in?
2.
What is your reference angle?
5, 6. Is 5, 6? Yeah.
It's 30, but yeah,
Oh, referencing.
just a reference angle. But you're right, I mean, it's the same thing. Okay, so 30, that's this finger. Cosecant goes with sine. Sine is your y value. So that would be 1 over 2. But this is cosecant, not sine. So I need to flip it over. So it's 2. And in quadrant 2, oh, it's positive, because sine and cosecant are both positive in quadrant 2. And just leave it as 2. Negative 5 pi over 4. So what quadrant are we in if we've got negative 5 pi over 4? 2.
Okay.
Because it's negative, so you start backwards. Your reference angle is pi over 4. Left hand trick this, that's your forefinger, fold that in. Sine is your y values, so it's these two. So it's 2 fingers, divided by 2, take the square root at the top. In quadrant 2, sine is positive, so it's square root of 0 2. All right. 240, what quadrant? Reference angle?
60.
60. 30, 45, 60. So that's this one. Secant goes with cosine. Cosine is your x value. So it's cosine would be 1/2. But I have to flip it over. So it's 2. In quadrant 3, it would be cosine